The first in our lineup of 5-minute talks will be presented by Mike Seibert. Mike, are you there?
Yeah, I'm here. Can you hear me?
Yep, I can hear you. Thank you.
Okay. Okay, now that my time's rolling, if we can just skip to the next slide, we'll get off the boring cover slide. We've heard a lot about the Apollo context for sample collection in presentations earlier today and yesterday. So going to just kind of skip over this slide a little bit more. The big thing is we've seen the images of the tools and sample containers used on Apollo. We've seen images of the tools being developed for Artemis. The Apollo context that I really have started looking at is that a lot of the collection systems, especially for Regolith, required both crew members. The images from a training exercise back during Apollo. But later systems could be operated by one crew member. The LRV scoop, which was a bag scoop, was an example of a single crew member capable Regolith sampling device. Next slide. Robotic regolith sampling, on the other hand, has actually been accomplished for quite a while, even actually dating back to prior to Apollo. There was the scoop on the early robotic arms deployed on the Surveyor missions. But on Mars, we have seen robotic scooping of samples and actually sample transfer to instruments. You can use that as a proxy for a sample collection container. It's been done on Viking, Phoenix, Curiosity, but so far, the only mobile scooping platform that we have really sent to date to Mars is Curiosity, and on the moon for mobile scooping has been the Apollo astronauts. So coming up on the moon, there's also going to be future robotic scooping capability with the sampler robotic tech demo payload, which I'm one of the co-eyes on, which forms the backbone of the concept that I'm going to talk about. So if we can move on to the next slide, which has the meat of the presentation. The notional system concept that we have been working on is for robotic sampling of regolith. This would be rover mounted, allow access to the surface to do bulk regolith sampling, and then depositing the regolith into sample containers that would then be able to self-seal. So this would be with the crew potentially in the loop to pick a selection site or a crew out of the loop. It's a robot arm that we envision being able to be mounted to the LTV when that is deployed, or a common system could also be used across multiple rovers, whether crewed or uncrewed. Next slide. So the big benefits of doing robotic regolith sampling, and I bet you're asking why we're talking about robotics when we're focusing on crew science. One of the big ones is consistent sample collection and caching. We can, with the robotic trajectory planning, we can have the scoop pass through a trajectory along the surface to collect a skim sample, just more of a rough scoop sample, or be able to even excavate some of the surface to acquire shallow subsurface samples. Also, there is potential ability to allow for sieving of samples prior to deposit in the sample containers or during deposit in sample containers. The big one, though, is that this would free up a lot of crew time on the surface. When the rover hits a station of interest, you'd be able to have the sampling system either autonomously collect a sample or be teleoperated from a location that isn't with the crew that is currently on EVA. Big benefit is reducing the collateral dust deposition onto these spacesuits. The Apollo image I showed on slide 1 showed it was a little awkward on the Apollo level spacesuits to be able to actually do that regolith transfer. We can adapt the system, as I mentioned before, onto multiple rovers. If you adapt it onto a pressurized rover, this could eliminate the need for an EVA to do a regolith sample collection. So the crew could effectively have this sample collected while they're drinking their morning coffee on a long traverse.
1 minute remaining.
Thank you. And with the expected remote operation of LTV and especially the LSSMS class rovers, the rovers could be repositioned slightly to allow for these targeted sample collection to occur when the crew is not present, either if the crew is off the rover doing EVA tasks in the immediate vicinity, or if the crew is not present on the surface in any capacity. Next slide. So going to the punchline, doing robotic sample, excuse me, on crew rovers allows you to have samples over a larger area collected during a much shorter time. The crew rovers move fast and cover a lot of distance. Had a fourth drive been occur on any of the Apollo missions with the LRV, their total distance driven would exceed that of the Opportunity rover on Mars, which is the current reigning rover champion. And this also allows these samples to be collected with less crew time required. So there's a benefit to combining robotics and crew operations. And that's my time.